Hi, everyone. Good morning. Thank you for joining us today. I am happy to introduce our session as part of the European Sustainable Energy Week, the extended program today. And our session is going to be focused on the agricultural industry. So it's called Together Towards Energy Efficient and Defossilized Agriculture. So thank you in advance for joining us, and I hope you learned a lot today. Next slide, please. Oh, we might give it a little bit before barreling on with the program, but this is our agenda for today. So we will start with an introduction to the sector, challenges to the agricultural industry as a whole to set the tone for our discussion later. We will then hear from our three presenters, which will be presenting three EU projects, TheGreeFa, RES4LIVE and AgroFossilFree. And then we will have a discussion session with those presenters and follow up with a question and answer session where you, as the audience members, can submit any questions to any of the presenters. I would just say that you can use the question and answer function in Teams at any point during the presentations or the discussion if you would like to ask a question. Next slide, please. So my name is Anna Spoden. I'm the Communication and Policy Officer at EUREC, the Association for Renewable Energy Research Centers. And I'm happy to introduce our three speakers today, Dr. Martin Buchholz, who will be presenting the TheGreeFa project, Dimitrios Tiris, the project manager at RES4LIVE, and Konstantinos Vaiopoulos, who is the project manager at AgroFossilFree. Next slide, please. In addition to, if you have questions, as mentioned before, please use the Q&A function on Teams, but we will also be using Slido today. So you can either use the QR code you see on the screen for the questions that we'll be posing throughout our session today, or you can join at slido.com with the number on the screen currently, 2606590. So we will be asking questions periodically, and that number won't change, so you can use that to participate in our session. Next slide, please. So our first, we'll start with a question to see the background of those presenting today. If you use the slido.com function, we just wanted to ask how familiar you are with the topic today, either having some solid background or just new to the topic and want to get some more information. Leave it a little bit. Yeah, the number again is on the side if you missed it before. Okay, so I think we can move on to the next slide. Seems like we have varying in backgrounds. I'd like to start obviously with a kind of an overview of the topic with an introduction to the agri-food industry and some of the challenges to it. Next slide, please. Okay, so the agricultural industry inherently requires a lot of energy. And this energy has mainly been provided by fossil fuels in the past. And due to the use of the fossil fuels, the agricultural industry is now a significant source of greenhouse gas emissions. As you can see in the black box at the top of the slide, agriculture accounts for 10.3% of the EU's greenhouse gas emissions. And One of the most energy intensive and fossil fuel rich sectors of the agriculture industry is livestock farming. So the livestock sector alone accounts for around 70% of all greenhouse gas emissions. This obviously leads to significant contributions to global climate change and the risk of food security. So novel fossil energy-free technologies and strategies have been produced, but they are struggling with implementation. There's still a gap between the development of such technologies and their actual adoption and availability on the local sector, particularly when it comes to small and medium producers who have more limited access to information and also to funding. Next slide, please. And as we can see, the global climate change is increasingly a problem, and it's increasingly also a problem for the agricultural industry in particular. Climate change is causing summers to be hotter, storms more severe, and there are periods of prolonged drought. And if you just look at the situation this summer, we had incredibly hot temperatures, and these extreme weather conditions are already influencing crop yields and livestock productivity in Europe. And the EU expects trade patterns to affect agricultural incomes in Europe in the future as well. The EEA released a report recently just on climate change and its effect on the agricultural sector in Europe, which is included in the slides, which will be shared later. And there's a new opportunity, obviously, to use renewable energies to increase sustainability, reliability, and cost stability using those renewable energy technologies. And it provides a new and unique opportunity for farmers to reduce their energy consumption, produce their own clean energy, and thereby become either partially or even completely self-sufficient. And we're already seeing the rise of these technologies, including solar energy, including PV and PVT panels, wind energy, hydropower, heat pumps, geothermal energy, biogas. These can all be used effectively in the agricultural sector to produce electricity and fuels. Next slide, please. So on the EU level, obviously the challenge is striking the balance between the needs of the economy, society, and the environment. The EU Green Deal has targeted initiatives that are relevant to the agricultural sector, including the farm to fork and biodiversity strategies. And these outline a welcome ambition to improve productivity, improve sustainability, and the resilience of the EU's agricultural sector, while also promoting the economic angle and the societal, improving the livelihoods of actors in the food value chain. But funding does remain a significant issue despite the common agricultural policies, particularly in light of the recent crises that we've seen, including the pandemic, Russian invasion of Ukraine, and the high temperatures this summer. Next slide, please. And then apart from the EU's greater ambitions, implementing the EU's far-reaching goals requires adequate investment and support on a local level. Farmers on a local level, especially small and medium-sized farmers, require supporting measures with regard to infrastructure. How would these energies be installed on their farms? What business models to use? How to organize the technologies. The next slide, please. So these all encompass some of the challenges facing the sector, as I said before, from environmental challenges, including sustainability, economic challenges with ensuring food security, reducing production costs, increasing competitiveness, and also societal issues with increasing working conditions, income, and this is all under the big umbrella of meeting the EU's environmental targets and mitigating the climate change crises and implementing clean energy strategies. And renewable energies have a central role in overcoming these challenges, and they can help reduce the negative impact of agriculture on climate change and reducing dependence on fossil fuels, which are unstable and costly. Next slide, please. So when it comes to addressing this, when it comes to implementing renewable energy and tackling the challenges to the agricultural industry, you will hear today from 3 different organizations who are working on addressing challenges to the agricultural industry and accelerating the development and scaling up of fossil-free agricultural strategies. These 3 organizations are TheGreeFa, RES4LIVE and AgroFossilFree, all focused on fossil-free agricultural practices. So excited you will hear from them shortly. They'll be presenting their projects. Next slide, please. If you have any questions for me in particular, you have my contact information here. UREC is involved in the RES4LIVE project as well. Next slide, please. I am happy to introduce Dr. Martin Buchholz, who will be speaking to you more about the TheGreeFa project, so thermochemical fluids in greenhouse farming. Dr. Buchholz?
Yes, thank you for the introduction. Very good, interesting. Yes, this is the first project of this group, and it's called the TheGreeFa, thermochemical fluids in greenhouse farming. So as you see, our focus is on greenhouses. And next slide, please. Yes. What does it mean, thermochemical fluids? So we use the hygroscopic properties of solutions like magnesium chloride, sodium hydroxide, calcium chloride, or lithium chloride. That means these are substances, salts in a solution, which have the ability to take up humidity from the air, water vapor from the air, and by taking it up, we have a phase change between water vapor and water, and this means a release of heat energy. So if you look at the right arrow in red, we can use 680 kilowatt hours if we move 1 ton of water from water vapor to water. And this can replace, in the best case, 680 kilowatt hours of gas if the previous heat source was gas. That means that the solution takes up water and becomes diluted. And by becoming diluted, it's like a sponge. It loses its hygroscopic property and has to be renewed. And that can be done on another place up to 10 or 20 or 50, even 50 kilometers apart, where cheap heat is available. That can be industrial waste heat or residual heat or solar heat, for example. And we can put this heat into the process of regeneration and can evaporate the water out of the solution and then gaining back the concentrate and can provide new concentrate for the system. Next slide, please. This is the heart of our system, the absorber. So this is the place where water vapor and the solution is in contact. That means that the air is blown into these absorbers from the bottom to the top, and the solution by gravity flows from the top to the bottom. So we have a counterflow of the 2 medias, and here the process of the water, of the dehumidification of the air takes place. Next slide, please. Yes. So what do we do in terms of agriculture? So in greenhouses, we have heat losses by aeration of the greenhouse. So we want to remove humidity. We have to remove humidity in a greenhouse, but also CO2 has to come in as a source. We are now trying to close the greenhouse partially or totally. And by this, replace the aeration, the air exchange, by an internal process where the humidity is captured by the solution, and we gain the heat energy back and can heat the greenhouse and can control the humidity. This is our basic function for continental regions. In the Mediterranean region, we have another look on the system. We also want to close it, but here the main limiting factor for the business is water, and a lot of water in the drought situation we have is now replaced by desalination. And for example, in Almeria, the biggest area of greenhouse production in Europe, we have already a third of water coming from desalination. And here we have the link again to the energy sector, because this is very energy consuming. And here we also try to close the system to get water into the desiccant and to use it in another process by condensation purposes. Next slide, please. So here is our Central European prototype. It's in Switzerland, in Zurich, and it's an orchard farm. And here on the perimeter of the photo, you see 9 absorber elements, which are proposed to dry the air in the greenhouse. So here we have, you see on the top left, a different system. We have a very closed system. The air is cycling through the absorber, and we minimize heat losses. And we developed a new system where we take humid air from the top of the greenhouse, from the roof area. We condition the air so it can be heated, cooled by a pre-process, and of course we dehumidify the air, and then we directly provide the conditioned air to the canopy of the crops. So through the tables, the air is implemented and can directly change the microclimate of the crops. Next slide. Yes, thanks. Here is another application. The principle is the same. We replace an open to a closed cycle. But it's a very different application apart from greenhouses. So this is a drying facility. So we are drying herbs, and this is also done with the absorber. So the normal process is to heat air with gas to bring it to the drying chamber, to take up humidity from the substrates, from the herbs or from the agricultural goods, and to remove humid air to the environment. And here again we have the closed cycle, in which the humid air is taken into the absorber, is dried and heated. So the latent heat is released back and can be redirected to the drying chamber in a closed cycle. Here you also see the regeneration process on the right part of this drawing. It can be on another place where waste heat, where residual heat or solar heat is available. And here we can regenerate the solution again. In this process, for example, we need a higher regeneration temperature compared to the greenhouse applications, because the drying of the goods is very sensitive. Next slide, please. Here's some results. On the left part of the top, you see the energy balance with the residual heat on the left part of the drawing. So it's on another place, taken and in the absorber, in the drying facility, we almost have no energy needs, only for pumping and ventilating. Whilst the traditional way of drying is involved in a very high heat energy demands. Also, we have some developed some operation modes where we handle with different levels of concentration of a desiccant to have, for example, a very low concentrated concentration in the beginning of the process, where the humidity of the herbs is very high, and in the end of the process, of course, the herbs become drier and drier. Then we need a very strong desiccant to still be able to dry these elements. Okay, thank you. Next slide. Here we have the other application for Mediterranean greenhouses. This is a part where I also work in. So this is the crucial point here is if we want to close a greenhouse in Spain or in Northern Africa, we have our a prototype in Tunisia with a partner there. Of course, we have the problem of overheating. The aim is to increase the CO2 level of the greenhouse air with artificial supply of CO2, and by this be able to also grow at maximum temperatures of 40 degrees. So we have to keep the maximum temperature below 40 degrees, and this is done here on the left part of the drawing. Is done by 3 means. So first, all the heat has to go out, not by air exchange, but by conductive heat transfer through the greenhouse foil through the cover. And we modify the cover in a way that this is doing better. We have some heat going into the soil, and we improve this process by increasing the water content of the soil by organic material. And of course, third, we use the absorber, and this is the drawing on the right side. So we circulate air between the greenhouse, from the greenhouse to the absorber and back. So this is the same principle than in Switzerland, but we have a very high volume flow of desiccant. That means we take up the heat, the humidity, but by this also the heat. And we bring a lot of quantity of desiccant fluid to a storage. This is the red part of the drawing. This is heated and diluted through the daytime, and we use this heat and the water which we have taken up for the night process. There we want to evaporate the water again with the heat we have stored and gain a condensation water on the inner surface of the wall. Next slide. And this is how the final market-related tunnel greenhouse would look like. This is a kind of zigzag shape in which we increase the surface of the greenhouse by 100%. So it's a double surface generated. So we have double amount of heat that can go out through this surface. And we have 6 absorbers here in this 120 square meter greenhouse, and we have a big storage of desiccant. And the desiccant is used from local salinas. It's a waste product. It's a final solution, which normally is going back to the sea. It contains a lot of magnesium chloride and magnesium sulfate, which is a good desiccant combination. Next slide. Here you see some photos of our first lab greenhouse where we do the testing. We are testing the different components of the system, and we are now about to build the second prototype. Next slide. A focus of our work here also at Watergy especially is the further development of the absorber. So it's a specific development where we have kind of textile cylinders where the desiccant flows down, and a very specific way of distributing the solution from the top to the cylinders. That's the photo on the right where you can see the desiccant is flowing over these pipes and is then distributed. I think. Next slide. That was my presentation. Thank you very much. We have a few minutes for questions, and yes, I thank you for your attention, and here is my contact address, and if you have any question to me, you can contact me. Thank you.
Anna, we have one question to Martin. Could you read it on the Q&A, please?
Yes, thank you, Martin, for your presentation. It's always also interesting to see the different approaches to different climates. So we have one question for you regarding the TheGreeFa project. How is the effectiveness in percentage of waste heat use? And what is the difference between types of waste heat?
To the types of waste heat, I can say that we can use, for the magnesium chloride, for the greenhouse application, we can use very low temperatures, waste heat temperature. That depends on the outside climate. In winter, it can be 20 degree or 20 or 30 degree. Maximum in summer, it's higher because the humidity and the content in the air is higher. Then we need around 50 degree. And we can also take or the best kind of heat energy is hot air, so which we have, for example, in cooling towers or in air conditioning devices. We can directly blow this air into the desorber to the regenerator and can use it directly. Otherwise, if we have a liquid heat source, we have to run a heat exchanger to transfer it to air. So maybe that's for solar application. It's the same. The best collector is an air collector, but we can also imagine to use heat which is generated on the backside of PV panels, for example, which is a high potential, and it's also contributing to overheating of these panels. And the effectiveness, I would say it's very effective because it's working like a wet cooling tower, and in some cases you are not allowed, for example, in cities, to use wet cooling towers because of Legionella. But with a salt solution, it's very hygiene, and you can use it instead of. So you can or even economize costs for heat disposal. Okay.
Thank you very much. Yes, and if anyone else has questions at any point during the presentations, again, just use the Teams Q&A function, and we'll be sure to get to your questions. So next, I think we can introduce the next speaker. I'm happy to introduce Demetrios Tiris from the RES4LIVE project. So the RES4LIVE is focused on the livestock farming industry, and particularly zero fossil fuel consumption with livestock farms. And Demetrios?
Thank you, Anna. Hi, everyone. My name is Demetrios Tiris. I'm a mechanical engineer and RES4LIVE project manager. And today we'll give you a brief overview of our project's activities. Next slide, please. So just a few things about the background. As the previous speakers mentioned, intensive livestock farming turned out to be one of the most energy consuming subsectors of modern agriculture, mainly based on fossil fuels, while at the same time electricity and thermal energy was necessary to cover the energy demands, which are strongly diversified. And as it turned out to be, in order to achieve a more sustainable livestock production and defossilize the energy needs of livestock facilities, within the EU, certain measures had to be taken. Next slide, please. So this is how the idea for RES4LIVE started. RES4LIVE began its activities on October 2020, and will last in total about 4 years. In RES4LIVE, 17 partners for 8 EU countries are participating, from Greece, Belgium, Italy, Germany, Denmark, France, Sweden, and Cyprus. Next slide, please. In which 8 of them are universities and research centers. We have 6 SMEs, one commercial pilot farm, and 2 international associations. Agricultural University of Athens has undertaken the part of coordinating the project. Next slide, please. So, what is the solution that RES4LIVE promotes? We would like to achieve 100% replacement of fossil energy in intensive livestock facilities by utilizing renewable energy sources. To that end, the combination of technology and solutions will be installed in 4 pilot farms. As you can see in this slide, these farms are in Greece, Italy, Germany, and Belgium. Several adapted renewable energy technologies, along with some standard, let's say, solutions, will be combined. Next slide. So the general approach of the project, as I mentioned earlier, is the adaptation of renewable energy sources and machinery, and the combination of them with commercial technologies, the design of pilot systems, the installation of the technology, and the testing, multi-level assessment in environmental, economic, and social level, and of course the replicability potential and the generation of impact. By the end of the project, we would like to have market integrated and cost-effective technologies and solutions, which of course would have to be also case sensitive. Next slide. So the main technologies that will be adapted in our needs, in the needs actually of our pilot farms, is the modular heat pump, biogas to biomethane upgrading technology, thermal PV system, thermal photovoltaic systems, retrofitted tractor to operate with biomethane. All of these will be communicating and operating with the help of a smart control system. And as I said before, they will be also combined in some cases with some standard renewable energy sources solutions that are more mature solutions. Next slide, please. So now I would like to give you a brief overview of our pilot farms, as well as the interventions that will take place. The first one is in Greece. It's an experimental egg production poultry farm in Agricultural University of Athens campus. It is a building that hosts around 500 pullets and 500 hens. Before the interventions of RES4LIVE, the building was operating with forced ventilation system to remove the thermal loads, and for the hens, and with thermal lamps for the pullets. Our goal is to cover 100% of the energy needs with PV production, with electricity produced by photovoltaics, and to install a heat pump to precisely regulate the indoor environment in terms of temperature and humidity. To that end, a heat pump, a smart control system, and a PV system will be installed, as well as several other innovations, upgrading as LED lamps. Here you can see some pictures before and after the renovation. the air conditioning channels that are already installed, our photovoltaic panels that are fully they are operating, and a couple of sensors already installed and receiving data. By the end of September, maybe early October, we are planning to also install and operate the heat pump. Next slide. The second pilot farm is a commercial facility in Italy. It is a swine farm. It's quite big facility in which we will intervene in two of its buildings. It is a nursery barn and a hog barn. We're planning to replace the existing LPG boiler in the nursery barn with a heat pump to cover the thermal energy needs. And also we are aiming at an increased COP of the heat pump by utilizing heat from a PVT system connected with geothermal storage. Of course, a number of sensors will be placed inside the rooms hosting the animals. Except for the environmental sessions, we also measure the energy consumed. In the other building, the hog barn is a quite tall building in which an external walls insulation will be installed, and the environmental conditions as well as the energy use will be monitored. Next slide. Yes, here you can see all the technologies that will be installed. Is the heat pump, thermal photovoltaics, geothermal energy storage, smart control system, and energy efficiency measure as insulation mentioned earlier. Also, you can see a 3D model of the heat pump to be installed, which is actually already manufactured. And during the next months, from November on, the installation in the Italian farm will be scheduled. The other pictures are the drilling that took place for the geothermal energy storage. And after some tests that were run, during the next month, the complete installation will be finalized. Next slide, please. Our third farm is an experimental swine farm in Belgium, EUSEW. Again, is a big facility with two interconnected buildings with a total area of 2,000, above 2,000 square meters, and it hosts a large number of animals. Here, our goal is to at least partially cover the energy needs of the whole farm by utilizing PVTs, thermal photovoltaics, and heat pump. The heat pump will is going to replace an existing LPG boiler, and it will operate. Actually, it will be two heat pumps, one operating at high temperatures and another in low temperatures, connected with the photovoltaic of thermal photovoltaics. And as said earlier, all the systems will communicate with the smart control system. Next slide. Here you can see an overview of the facility, the place that environmental monitoring will take place. as in the other farms, except for the environmental sensors, we will also record the energy consumption. On the right side of the slide, you can see the 3D model of the two heat pumps, which the manufacture process will start during the next month. And the design of the system that will connect and connect the heat pumps and the thermal photovoltaic panels, solar station, being developed, finalized as we speak, actually. Next slide. And our last pilot farm is an experimental dairy cattle farm in Germany, in Potsdam. Here we have the facility hosts a large number of animals, of the main barn, welfare barn, and a young cattle barn. And right now, the farm has an operating biogas CHP plant and a milk cooling system. Our interventions will focus on upgrading these technologies by utilizing the produced biomethane from the biogas and the production of the PTTs. We are aiming to reduce the overall energy consumption. And the biogas unit, as I said before, will be upgraded in order to produce biomethane. A biomethane tractor is almost ready. Is a tractor that was using diesel and now is converted to use biomethane. And during the next month, will be transferred in the facility in order to begin the proper tests. Thermal photovoltaics will be also installed in November. Of course, the span control system will be present, and hopefully we will also have a chance to test an electric tractor for the everyday works to see how all these technologies fit together. Next slide. Yes, here you can see some pictures, some 3D designs of the biogas upgrading unit and the biomethane tractor. And actually, the upgrading unit is almost finished. It is planned. The works are going according to the plan, and it will be transferred to the facility, the livestock facility, by the end of October. This is on the left side of the slide. On the right side is the converted tractor, which is fully operational right now. Only some tests we ran some tests for more details about its performance. Of course, we have other works going in the farm, including the installation and monitoring of weather station and other sensors. Next slide. So the big picture of what RES4LIVE tries to achieve is to come up with advanced and cost-effective technologies for the livestock sector in order to achieve the sustainable farm operation of the farm, and also provide as much as possible thermal comfort for the hosted animals. In this way, we believe that increased productivity with minimum climate change impact can be achieved. And at the same time, we believe, we hope that we will create forefront knowledge about the deployment of renewable energy sources in the livestock sector. And hopefully, this could be lead the way to job growth and competitiveness in EU by improving also the quality of life of the European citizens. Next slide. So that's all from my side. I would like to thank you for your attention. You can reach out to us in our email addresses and social media, and at your disposal for any questions. Thank you.
Thank you, Dimitris. We do have a couple of questions for you. In the face of the energy crisis now, do you see it feasible to scale up the project solutions?
Actually, this is our biggest challenge. We see RES4LIVE and the other projects as the means to test these technologies. I believe that we have to actually, it's not a matter of choice. But yes, it seems that the first results seems that this is something achievable. But as our project matures and the installations will be finalized and its performance will be monitored, this will be done in a year from now. In 2023, we will have more solid results to present.
And there was a question about the use of biogas in tractors. How big are the modifications needed to adjust the motor to the new fuel? I guess that be more of a CRMT question.
Yes, this is a bit technical one. Maybe we can exchange some emails to provide further details. Actually, the tractor will operate with biomethane, not biogas. The biomethane will be the biogas in the livestock facility will be upgraded to biomethane, which is it's more efficient fuel. The tractor had to be modified in many ways, especially its engine. The whole architecture of the chassis in order to store the fuel, as well as its electronics. What we want to see after its operation is the cost effectiveness of this process, meaning it is better for the farmer to buy a new tractor or to modify an existing one.
And I will also mention that if you go to the RES4LIVE website, there's a lot more information on different aspects of the project. There's practice abstracts about implementation of the different technologies that Dimitris has mentioned. There's another question, which again is more of a technical question about the biomethane unit at the biogas in the farm in Germany. It says is the biomethane upgrading unit already functioning with the CHP unit? What is the size of the biogas plant on the farm in Germany? So again, that might, I don't know if you're able to answer that one.
Right now, I don't have these details, but the biogas plant is a functional one, working as a CSP unit. Its operation will be its stop for the biogas upgrading unit to be installed. It is a medium to small to medium size biogas plant. I hope that it helped a bit.
Right, and again, for a lot of the technical specifications, we'll be publishing our findings and documentation. Those will all be available on the project website. I think that's everything. Now we can move on to the next presentation, which is AgroFossilFree project. And I'm happy to introduce Konstantinos Vaiopoulos. Konstantinos?
Hello, everyone. I'm AgroFossilFree project manager, and I'm working for the Center for Research and Technology, ELAS, and together we will see the AgroFossilFree project. Next slide, please. Global agriculture relies mainly on fossil resources for covering most of its energy needs and supporting agricultural productivity in both open field crop production, like arable crops, orchards, vineyards, and control environment agricultural constructions like greenhouses and livestock buildings. The positive impact on productivity and efficiency, but also on labor intensity and workers' fatigue, has been significant, but the impact of agricultural activities on the global warming potential became extensive through greenhouse gases emissions directly emitted from livestock digestion and agricultural machinery, and indirectly through land use intensification and agricultural input application. Next slide, please. So the idea is that we have some innovative technologies today that can help us producing greener, and they are already being used for many sectors of economy like households, industry, and transport in the Europe the last 20 years. But they are not applied in agriculture with the same intensity. And the reason for this is that they are not agriculture is not considered as a main energy consumer and greenhouse gases producer, but also such technologies have a high cost for small, medium farmers due to their low income. Next slide, please. So nowadays, market growth has allowed optimization of the solutions and lower prices for them. And in combination with energy efficiency and rational use of energy, all of these technologies and solutions have been more appealing for all sectors, including agriculture. So the problem that we have detected is that in agriculture, there is an important gap between these developments and the actual adoption of them. And we're trying to bridge this gap by gaining knowledge of existing and future technological advancements in order to achieve what? Full alignment with the fossil energy use reduction policies, and the related legal and regulatory frameworks, and sustainable food production and practices. Next slide, please. So, AgroFossilFree participates in the call for defossilizing agriculture solutions and pathways for fossil energy-free farming, and the title is Strategies and Technologies to Achieve a European Fossil Energy-Free Agriculture. The budget is 2 million euros. The duration is 3 years. We are entering the 3rd year now, as we started on October 2020, and 16 partners are collaborating on this for EU countries like Greece, Denmark, Poland, Belgium, Italy, Netherlands, Ireland, Germany, and Spain. Next slide, please. The key element of our project is based on FEFTS. FEFTS is an acronym for Fossil Energy-Free Technologies and Strategies and refers to 3 main pillars. The first one is on-site renewable energy production. The second one is energy efficiency and rational use of energy in agriculture. And the third one is soil carbon sequestration. Next slide, please. So when we're talking about FEFTs, technologies and strategies, we're referring to all the agricultural applications where we can use them. So regarding FEFTs for clean energy production, we refer to technologies that can produce all types of energy by all possible renewable sources like solar, wind, hydroelectric energy, biomass, biogas, biofuels, geothermal energy, etc. Regarding energy efficiency improvement measures, we refer to all applications for open field crop production and controlled environment agricultural facilities, as we said before, like greenhouses and livestock facilities. For open field agriculture, we can think about energy efficient machinery use, optimized field operations, smarter irrigation, variable rate inputs like fertilizers. And for a controlled environment, greenhouses and livestock buildings, we can think of solutions like efficient lighting, dehumidification, heating, cooling, air conditioning, intelligent energy management systems, etc. Regarding soil carbon sequestration, we refer to methods and practices in order to enhance the soil matter, the organic matter of the soil, and increase productivity. Next slide, please. So the approach that we use in this project is first to start with the research and make an assessment of EU agricultural energy status and farmer needs. For the EU agricultural energy status, we have made a research on that, and we have produced 3 research publications, one for open field crop production, one for greenhouses, one for livestock facilities, regarding all the energy that is used on these sectors. And of course, you can find these papers on our site. And regarding farmer needs, we have conducted a survey in more than 400 farmers, asking them about their problems, their needs, their incentives, and what they need in order to adopt these technologies. The second step was towards knowledge, as we say here. So we created an inventory of FEFTs, and when we say FEFTs, we refer both to research papers, projects, commercial products, training material, and financial tools. The third step was to make multi-actor networking. So we organized 3 regional workshops in each country and another 3 transnational workshops in order to gain the knowledge and the interaction between all the stakeholders of agriculture and gain some knowledge again about what they believe is the problems and what are the new ideas that we should recommend to EU. In order to collect all of these and in one tool, we have created Ag Energy Platform. I will show you next the link and how it works, where more than 900 vets are there right now. And the final step is about producing policy recommendations for the EU regarding the feedback that we have received from all the activities of the project. Next slide, please. So the structure that we have is presented like this, and the center of all of this is the Ag Energy Platform, and the approach that we have adopted is a multi-actor, as we have involved stakeholders of agriculture in all the steps of our activities. Next slide, please. So this is the platform. As you can see, the URL is platform.agrofossilfree.eu. You can scan the QR on the left. You can see that there are scientific papers, research projects, commercial technologies, and training material and financing mechanisms in order to adopt fossil energy-free technologies and strategies. Next slide, please. Here you can see that on the left, there are filters where you can search about specific thefts and make any selection that you want in order to find new solutions about energy efficiency, about green energy production, and it is all inclusive about everything that refers to energy and agriculture. Next slide, please. So where we stand now? As we have said, the objective is to achieve more than 1,500 thefts. Until now, we have 900 in our platform, and 1,500 will be available during the next month. About farmer needs assessment, as we said before, we have made interviews with 470 farmers in order to gain feedback from them and about their problems and their needs. Regarding AgEnergy platform, is working more than 2 years, more than 1 year now, and it contains a lot of facts in order to provide knowledge about energy and agriculture. Regarding policy guidelines, we haven't produced yet policy guidelines, but they will be produced during 2023. We have produced 21 practice abstracts for our farmers with practical guidelines about all 3 sectors of agriculture. We have completed all the series of interactive innovation multi-actor workshops, 24 in all the countries of our project, 8 countries, by the way. And we have made 2 transnational workshops and 1 to go in order to complete all the feedback that we'll gain and produce the policy recommendations. 1 brokerage event will happen during June 2023. Next slide, please. So that's all for me. Thank you for your attention. Please visit platform.agrofossilfree.eu. We invite you to engage, and we are ready to answer every question that you have.
Thank you, Konstantinos. There is one question which is focused on, which is centered around Romania, where there's a low awareness on the networking possibilities for farmers due to multiple factors. So the question is, what are some, or can you recommend some accessible tools that would help the situation in raising awareness?
I can talk to you about a specific tool that we design at the moment. It is a decision support tool that will be incorporated in our platform. And in about 1 or 2 months, where we will have completed, every user of AgroFossilFree platform will be able to make some selections about his farm, what he grows, and what is his status. And the decision support tool will provide to him some solutions, some recommendations about specific technologies that he could, she could adopt in order to be more energy efficient. So this works with artificial intelligence, and it's a very nice tool in order to engage people that are not really familiar with this kind of solutions. Did I answer, or there is another part that didn't answer, Anna?
No, I think that's helpful. You can also type that website address where it'll be found. But yeah, I think that's helpful. And I think we can now, if there aren't any more questions, which I don't believe there are at the moment, again, anyone attending, you're welcome to submit your questions to the Q&A function. Now we'll move slowly towards the discussion section. First, we have a couple of Slido questions. As I mentioned at the beginning of this session, you can join at slido.com or with the QR code you see on your screen. So the question is about how much the 3 projects we presented can help overcome the challenges to the agricultural industry. So if you'd like to submit your responses, 1 being not much at all, 5 being very much, we will leave that open for a bit. And yes, as our moderator Emil says, we will have the presentations available for you and a recording after the session today. So both the video stream and slides. So if you have any questions, you would like to look back at the presentations, you will be able to do so. And do follow along the website of Area Zero. It's been posted in the Q&A for project relevant information. So seems like the project generally proceeds as very helpful, which is always good to hear. I think we can move on to the next question, perhaps. Second question we have on Slido is if you find the results of the EU projects like the ones we presented today, so RES4LIVE, AgroFossilFree, TheGreeFa, easily accessible. So obviously it's always important that these projects are able to get their information out to the public and to relevant stakeholders who need that information. So any feedback is helpful. And while you guys are answering that question, I think we can, I'll set the stage that we're going to have now a discussion session with some questions for the three panelists you already heard from today, and followed by a Q&A session. So if you have any questions at any point, please submit them to the Q&A function in Teams, and we will, of course, get to them. Yeah, so if I'd like to have all the panelists. I'll ask a couple of individual questions first, before getting to kind of some that are relevant for all three panelists, because there's obviously overlap in their projects. So I guess I'll start with Martin, Dr. Buchholz. Obviously you're focused on greenhouse farming in different regions, but we're now dealing with a lot of with an energy crisis, or multiple crises actually. So what are the implications of the high fuel and electricity costs on greenhouse farming in the Mediterranean region, for example, where you say you specialize?
Okay, in the Mediterranean, we have a long water crisis already. So this results in overconsumption of groundwater stocks. But this is also part of the business. So the areas which have water, they profit a lot from this and have a very high advantage in the competition. And when you switch to desalination, this is a bit going. So the business is so good if you have water that the greenhouse areas grow. They can grow like crazy, like into hundreds of square kilometers of greenhouses. And then automatically you come to the point of overconsumption. And if you want to replace water, groundwater, which is almost free, you just have the pumping costs. By desalinated water, of course, it becomes a relevant cost factor, and this is relatively similar to all the regions in the Mediterranean, because it's a market price, a world market price energy, and then this changes a lot the competition, and if we stuck on desalination as a solution based on fossil fuels, this is very critical. And if you just replace fossil electricity, let's say, by photovoltaics, it's also not the solution, because you may need the same surface of the greenhouses again for the photovoltaics. So it's also a surface question, and of course money, an economic question. So it's very complex. It's very close to what we call the water energy food nexus, and yes, it's our work is not so influential at the moment, so it's still on the research level of improving. But the idea of using the energy, the heat energy, which comes into the greenhouse mainly for the water recovery, and may also include desalination elements. For us, this is the solution for the future.
Right, yes, obviously for long-term solutions, you need some innovation currently, so that's very important. I would like to ask a question specifically for Dimitrios Tiris from the RES4LIVE project as well. You talked about a bit different farms and different tools. So can you talk a little bit about the rationale behind RES4LIVE's interventions and the project?
Thank you, Anna. First of all, we had to identify what were the needs of each individual farm, what intervention points, if you like, would be. At the same time, we had to pre-screen some technologies that they were more or less established, but add a twist into them in order to better fit both the livestock sector in general, but also the specific livestock facilities that we chose in our project. What we try to do in practice in our facilities is to, depending on their size, to completely to cover their energy needs completely by renewable energy sources when that was possible. This is the case. This is this was the goal behind selecting these technologies. This, of course, can be achieved in the framework of the project, with the budget of the project, in small facilities as in AUA's egg production farm. In the other facilities, we chose to focus in specific buildings or specific energy consuming operations. But yes, this was the whole idea, and at the same time, these technologies to be in position of offering the highest possible thermal comfort for the fossil animals. So that was the rationale with these two main pillars behind the selection of intervention technologies and interventions.
Thank you. Yes, obviously also the fact that you have 4 different sites and different specifications, different livestock definitely helps the application across a wider sector.
Which is, but I mean, yes, it's on the one hand, yes, but on the other is turned out to be very challenging goal. But that's why we participate in this kind of projects.
Exactly. And then a question for Konstantinos from AgroFossilFree about so we've heard from kind of the livestock angle, but for more crops, what is the greater energy input in open field crop production systems? If you could talk a little bit about that side of the agricultural sector.
So Anna, as we said before in my presentation, there are both direct and indirect inputs, energy inputs in agriculture. Most of us would expect that direct inputs like fuels would be the greatest energy input in agriculture activities for open field crop production. But after our research in this sector, we have found, and we have made a very nice research publication, that the result is that fertilizers stand for more than 50% of the total energy inputs in open field crop production. And after fertilizers, diesel use comes with 31%, seeds with 6%, and all the other inputs stand for 8% of the energy inputs. So fertilizers stand for more than 50% for main crops like wheat, maize, barley, sugar beet, rapeseed, and olives. And when we talk about energy and fertilizers, we can think about the energy that is needed in order to produce the fertilizers and to transport them. So the solutions to decrease this energy waste would be to make more rational use of fertilizers, variable rate applications, etc.
Thank you. Yes, and I'd like to kind of open a question to all of you. You've obviously presented your projects, but what are the biggest challenges faced by your projects up to now, and how have you addressed them? We'll start with Martin. Maybe we'll go in order of presenting, Martin, then Dimitris, then Konstantinos.
Okay, the greatest challenges at the moment are technical issues, of course, at our project, which works on a kind of innovation technology. There are many. If I look at our Mediterranean prototype, it's the first thing was to get the greenhouse really closed. So it's not just closing it a little bit. So because we need to go close to the dew point to get the condensation, and if there are leakages, it's not working. So there is not too much dry air coming back into the system, and we try to find out where are leakages, etc. Second is overheating, of course. So the system needs to be very efficient at a short time of the day, let's say from 12 to 4 p.m. or 5 p.m. And at this time, an enormous amount of heat energy has to be removed. But if the phase change of water helps a lot with that, because it's a good way of, it's like the heat pipe effect. It's a good way of transferring high amounts of water, of energy at low temperatures. So I think we are on a good way, but it's still challenging. And third is, and I think that's for all the applications, the regeneration. So we are actually trying to have the regeneration through the nighttime, but it's not clear if it is enough heat energy or enough temperature, especially to have the optimum regeneration, or if we need external devices for the regeneration. Then of course the costs go up because we need additional equipment, additional surface, etc. I think these are the main challenges. In that way, I think if the focus is heating in the Central European applications, we are a bit closer to the solution because we compete with gas. On the other side, we only compete with groundwater limitations or desalinated water. It has a lower energy implication. Okay.
Thank you. Dimitris, if you'd like to address.
Yes. Well, of course, there are many technical challenges and many more to follow because right now we are the design phase of the integrated solutions is almost over. It proceeded smoothly, but during the next months, we will have to install and test the solutions in a real environment. It's fun because of the difference in the hosted animals, the environmental conditions, had different challenges, different difficulties, different needs that we had to address, and also different schedules that we had to follow. So also in terms of coordinating the works in each of them, we had difficulties, especially during the first months because of the pandemic and the fact that we couldn't travel. We had to plan everything via telcos, etc. In general, what is and is a big challenge is to how we will adapt technologies that work well in certain environments, like in domestic environments, let's say, like heat pumps, in order to meet the needs of a totally different operation, let's say. This is more or less. I won't take more of your time in order to progress the also other things.
Thank you. Konstantinos?
Regarding AgroFossilFree, I would say the main challenges that we will face until the end of the project will be to try to depict as realistic as possible the feedback that has been gained by all the agricultural stakeholders that participated in our surveys and in our regional and transnational workshops that we have conducted, and to incorporate all the knowledge gained in the policy recommendations that we will produce for the EU. A second challenge would be to make nice and interesting videos on successful case studies. So we're trying on that. We're working currently on that, and we will share these videos with you next year when they will be ready during 2023. And the third, and let's say the major challenge would be to make our platform, AgEnergy platform, as popular as possible, engage stakeholders to use it, engage them to assess the solutions and upload solutions. So make the platform alive and keep it alive with the audience. These are the challenges that we face, and we hope that we will achieve and overpass every one of them.
Thank you, Konstantinos. I think we have now another Slido question even, so we might move on to the next slide. Again, if there are additional questions from the audience, please use the Q&A function, and we still have a space, allotted time for Q&A, so we will be sure to answer your questions then. So the Slido, you can see on your screen, if you think current EU policies adequately support defossilization with regard to agriculture. Obviously, we all know that there's still much to be done when it comes to making the agricultural industry fossil-free. But the question is if the support's there. So it seems like not enough support, not at all. So there is still ways the EU can improve. And I think we have, yes, now we have any more questions? If there aren't any other questions from the audience, I have plenty at my disposal. So I might ask Martin and Demetrios about next steps for your projects. Obviously, you have some kind of technical you have technologies that you're developing, work from the tractor to specific systems on farms. So what are the next steps for the two of you in scaling up and really implementing the solutions of your projects on a kind of European level or on local level even? Martin, I might start with you. Okay.
Well, I talked about the technical issues, but provided they are solved enough to have a working, maybe not commercial economic system, but a technical working system, we should have a scale up of the system. Let's say now we have a 12-meter greenhouse, tunnel greenhouse. Let's make a next step a farm of 1 hectare or so, or stepwise. Let's turn 10 meter into 100 meter, and then maybe to a hectare or so. I think this would be very powerful to show that a whole farm could work on this system and would economize water. So economizing water means, in our case, and we have already proved this in other projects, 80% of water recovery, and that's very much. And if you have condensed water as a water source, it can also be mixed with brackish water, for example. So this could open a lot of potential areas which become interesting for greenhouse farming. The same for the Central European applications. Here we have a center in Belgium and the Netherlands, and this is also in an industrialized area, and here we have a lot of residual heat available to create kind of desiccant networks and to provide energy efficient technologies to the greenhouse sector in total.
Thank you. Dimitris, if you'd like to quickly address the scaling up of solutions.
Yes, very briefly. So, of course, our next steps are to install and test the technologies and the combination of these technologies, that many of them are implemented for first time in livestock facilities. But the research has to deepen and to be focused in specific technologies in order for them to be able to achieve scale up. And it would be ideal if policy measures as subsidies will be given to the livestock producers in agriculture in general to have the chance to test these technologies in real environments. So I think that this last one is crucial for the future.
Perhaps Konstantinos, one last question. I know we're limited on time now, but if you'd quickly like to address some of the barriers towards the fossil-free energy transition that your project has identified.
Yes, thank you, Anna. During our interviews and the questionnaire that we have provided and all the contact with the farmers and all the agricultural stakeholders, we have understand that the main problem is bureaucracy and all the problems that has bureaucracy as their source. A second problem that has been identified is that farmers don't think that the policies are stable enough in order to make them secure to invest in such technologies and all these innovative wave that we're living currently. The third, let's say, barrier and problem that we identified is that there is need for specialized subsidies, as Dimitrios said before, to specific technologies in order to install them and adopt them. In addition, farmers think that there is no, it is not so accessible. The access to information is not so possible for them, and when they're reading about new technologies, they're not sure about their reliability, so they need to ensure this thing. And when they read about the new technologies, to be sure that the news is pretty legit. And the final one is about need for supporting advisory systems for them in order to give them advices about the new technologies and how to adopt them and how to familiarize with them.
Thank you. Yes, so I know we're running out of time here, or we are almost out of time. We have one last Slido question. If we can takeaways from the event, what was the most interesting message in a couple of words? And we obviously like to get any feedback. And while those are coming in, I would also just like to thank everyone for joining us today. Thank you to our speakers, especially for taking the time to present their projects. And thank you for your questions. The 3 projects that were presented today are on your screen now. I would invite you to check out their websites. All 3 projects are members of the Area 0 cluster, which is the Alliance for Renewable Energy in Agriculture and Zero Fossil Energy. It includes 6 Horizon Europe projects that are collaborating and have similar interests regarding decarbonization in the agricultural sector. So thank you everyone for joining us today. Our slides and video presentation will be available if you'd like to look back, and hope you all have a very nice Thursday.